address resolution protocols. Address resolution protocols, it means then it is a data link layer, not even a network layer and transport layer. In the network layer, then you can talk about IP address. Transport layer, then you talk about a port, a specific port. Some many applications needs to go through that layer, network layer. So they use their own specific port. In the presentation layer, transport layer, the protocols available in the transport layers, two major or three, ICMP also, but UDP and TCP. So I want you to understand the difference between UDP and TCP very, very carefully. Has been addressed in the slide. Today we will see how that difference can be implemented in Python. Therefore, client and server simply it talked through TCP protocols or UDP protocols clearly. Why that is UDP, why that is TCP, because of that codings. Before the the IP address is resolved, before reach to a specific IP address, then ALP protocols is used. That is usually depending upon the interface card. So ALP protocols. In my textbook, so ALP protocols can be implemented in Python if you are working on Linux operating systems, but not on Windows. On Windows, Python works only within the IP address, so you can start from IP protocols. So you cannot handle ALP protocols. But if you're working on the Linux operating systems, then ALP as well. In coding, I'm talking about in coding, okay? In Python coding. Some of the courses you may be able to see this using Wireshark, but I'm not going to repeat this again. There's two shallow levels, and you can make some fun. But internally, how they are working, that has been coded in detail in my textbook. Those who are interested in. Okay, here let's first talk about TCP server. I am going to open up the code. This is a TCP. At the same time, I am going to open up UDP. So if you see these two code, on the left, this is TCP. As you can see here, TCP server. This is object-oriented type, but we didn't touch orientation in Python, right? So forget about this. But inside here, there's a function definitions, right? Forget about these function definitions. I want you to see this. This is a socket constructor. You need to import it. So this is the package sockets. So you need to import all the modules available in the socket package. In that socket package, we have socket class available. This is a socket. Socket. This is a constructor. If you are working on Windows, then you need to use this family, the address family, right? init families. This is a type of network. So this is a must, okay? Socket stream. If you do socket stream, then it is talking about TCP. On the other hand, if it is UDP, then look at this. This and this. There's a difference, okay? Sock underscore stream, then this socket is constructed to set up TCP communication. If you say sock dgram, then hey, my program needs to communicate over UDP. Okay. TCP and UDP is TCP is a connection based. UDP is connectionless communications, which means between the server and client, there is no connection constructed. Only send one time and receive. That's it. Connection is not. Connection doesn't exist. Doesn't remain. But TCP connection needs to be established, so they send multiple packets can continue to send through that connection. So connection is very, very important in TCP. UDP connection, no. Where you can see that, here's the thing. Both the UDP and TCP, as I said, they need to, any program, any hardware, when they need to communicate with others, they need to have a port. Like you guys, if you want to go out of the States, then you can go out, or you can come in through a port. It could be seaport, it could be airport, right? Unless you slip in, right? But anyway, legally, right? Port, through the port. So binding is important. This guy, TCP bind to the port. UDP also bind, okay? After port assigned, TCP needs to construct. This is a construct. See here, this guy, TCP listen, and when client comes in, then accept that request, the connection request. After that connection is created, remember that this accept function returns these things, 3 elements: connection and remote host and remote port. Soon as the TCP server accept, then TCP server knows remote host, remote port, and connection. However, UDP, after binding, no nothing. Simply, if there is some data comes in, receive the data. Look at the code from this bind, between bind and this receive. There's no nothing specific, right? Simply receive it. When UDP receives, then there is a message that carried an address. Okay, that's it. Here, this guy has connection. Connection object is created. TCP, when TCP server accepts the data, then connection is created. So through this connection, then they continue to communicate between TCP server and TCP client. Look at this CON. CON is used. Through this CON, receive data. Through that CON, send the data. Con.receive, con.send. Okay, that is TCP. On the other hand, this UDP, when UDP receives the data, there's no connection, but S dot receive from. What is S? S is a socket. Socket itself receives, so no connection is established. Socket receives it, and when returns, socket send it to. Right? That is a big difference. UDP, socket by itself receives the data, socket by itself sends the data out. TCP, once the socket accepts the request, then connection is established. After that, connection receives, connection send. In between, this is while loop continues. That connection, and then after that, connection needs to close. Okay. This is UDP. You see this while loop here. They're all sockets. There's no connection. Socket receives, socket send. If this communication completes, then socket closed. Socket closed, socket completely closed. And then socket is re-established to receive the data. So every time when you send UDPs, one-time send, and 1 second later you want to send again, then already socket closed. So new socket is created, open and close, open and close. That is UDP. TCP, while they are communicating, still connections. Socket, of course, the socket is still alive all the way. Okay, I didn't close the socket here, but it should be closed. Right, automatically, if connection is done, then socket is closed. Okay, there is a difference between TCP and UDP. So let me go ahead and close this, and then I want you to take a look at the client side. Let me use a UDP case, client and so. TCP also similar. This is a UDP server. Remember that we looked at already, right? Socket receives and socket close. Socket send to. That is a UDP server. Here is UDP client. All right. So both server and client needs a socket object. So socket needs to construct a socket object constructed through this diagram type, same diagram type. This socket and that socket, server socket and client socket, exactly the same code. And once this client does not need to bind, but server needs to bind. Therefore, if server, hey, I'm going to open this port number, 53,535. This UDP server get this port number. Then client needs to talk to that port because server opened that port. So any client needs to talk to, then that talk through this port number, same port number. So this UDP client does not need to have any bindings because client doesn't make any service, but server needs to be ready to give services. So binding means it open the ports. Client, once the socket object is constructed, look at this, don't do anything, right? Only here make a messages. I said the input, this is user interaction, right? Message to send to the server. Then user enter the message. Then this is local host and port number. Port number is when this guy client is sending out, then port is immediately temporarily assigned. So that's a port number. We don't need to give port number here. Okay, simply that is assigned. Oh wait, this port number is here. That is this guy. Yeah, that's a server port number. So address here. Okay, let me take. This address is not my address. This is a server address. So this is a server IP. This is a server port number. Currently, we are talking about within the same device. So localhost and port number is this. When we call this client.talking, then comes here talking functions. So that number is this port. So that port is this port. This port is a server port, which is here. And then it's a trial. If a message quit, then it's quit. Other than that, here is a send to. Okay. C is a socket. Here I said socket object is called S for server. This is variable, right? For simplicity, I put here a socket object for client. I put the S. So S is also socket object, but named C as client. So this socket dot send to, and then this message is encoded and then send to this address. So that is the address, local address through this port. Through this port, it goes to the server. I'm talking about here. And when it receives, it also receives by that client object. So receive it from the server. So it displays that one, like here, print. All the print statements is just simply displays. Okay. So let's export it. In order to do that, we need to. We can do that in the terminal, on the terminal, not Paizo. So what I am trying to do is this left-hand side the server and the right-hand side client. And okay. So change the directory. So I copy this and come back here, CD and paste and change. So I'm in this directory. Same thing here, CD and that path address. And then I am both of these two terminals are here in this directory. What you need to do is that you need to first construct a UDP server. So Python UDP CLAS server2 cont.py. That is this one that we already have, right? That should be run. So server is ready. I hit enter. The server is ready. Client is this, right? So I will do here Python UDP CLAS client to count.py. Remember that the client, this server already bind the port number, 5,000 something, 50,000, right? So the server is ready. Client first ask you to enter the message. Then this guy server client already knows IP address, server IP address, and server port number in the program, right? So hit enter, then this guy says a message to send to the server. So I said, hello, UDP server. I'm going to hit enter, then watch the other side. What happens here is that in the server side, when I hit enter, then it receives and decode that message. Decode and encode is this. This is a Python issues. When the data is loaded on the network, it should be encoded. That way it can go through internet. And when it receives, and if you want to display it, then you have to decode it. So encode and decode that is needed. There's another issue, right? You may be able to learn this some other courses. But anyway, when it receives, then decode, therefore we can see it in the print statements. So at the server side, something received something from something, colon something. So 4 variables. So first one is the server name, whatever server name here, there's a server name, .u and UDP server. That server name received, second blank is message, received whatever here, hello UDP server, that message appears here, from something colon something. Address, this is the list. So first element in the list address appears a third blank and fourth blank with the second element. Address here receive this message. When it receives a message and address together. Receive and address together. How come? Because we set up that way. When we send this message, here is a send to. First element is the message, we encode it. Second element is the address. Because I send both message and address, as it receives a message and address. When you say address, then address has a local and port number. So that thing can appear here. Okay, this and that. So watch. So I'm going to hit enter at the client side. Then immediately at the server side, it receives this message and address, and it echoes to display here. Okay, so now hit enter. Hit enter. So this guy has Dr. Yun UDP server received John's UDP client, and then this is a message, hello UDP server. Hello UDP server. Okay. So, and then this client And then server returned. Server says, good to hear you, John, because that message already replied, right? John's UDP client. So server knows. So good to hear you, John. Enter. Enter. Then that comes here. Dr. Yoon's server said, good to hear you, John, from there. This continues. And then at the end, if you want to say quit, then it'll quit. So both the server and client quit. Okay. This is very similar to the TCP as well. So as you communicate, you do not know whether it is a TCP or UDP, but internally, clearly, they are not the same. As you see here, this UDP, this is message-based communications. So connection is not established, but UDP connection established. I mean, TCP connection established. I want you to watch this video carefully and practice it if you want to do the TCP case as well. And then also you can open up a multiple client, not only one, but multiple client. That is a whole feature of client and server, right? One server can serve multiple clients. You can open up multiple client terminals, and you can talk one terminal to the server, and to the same server, you can communicate through different clients. You can see how they behaves. Okay. Once you know this, then when you set up client to server, packets flies between server and clients, and those packets can be extracted by your Python programs to extract the content payload. That's addressed in that textbook. So even much beyond this implementation that you can practice, but that's beyond this course. But anyway,